All right, let's get started. I'm Vaughn Vernon. I'm happy that you have decided to attend my talk. I have a company named For Comprehension. Maybe you're aware that a for comprehension is, or a comprehension in general, is a functional programming construct where you make an expression and this expression results in, for example, a collection of elements as a result of iterating over and filtering and merging a collection of elements. In the Scala language, this is known as a for comprehension. On forcomprehension.com, we offer online training and live learning, and also consulting and mentoring services around domain-driven design and reactive programming, including the actor model and the development of microservices. I'm the author of this book, Implementing Domain-Driven Design. I'm also the author of two other books. The book that I'm going to give away after this talk is Domain-Driven Design Distilled. And I'm also the author of a book called Reactive Messaging Patterns with the Actor Model. What I see when I go about my consulting services, consulting with various companies of all sizes, I want to make this clear. It's not just large companies or medium-sized companies. This is from small companies all the way to large companies. They all have a very big problem. The problem is that projects are in peril. And we have sort of a group of people that the company views as uber geeks who are on a daily basis keeping software, whether it's a subsystem, an entire system, they're keeping these services running on a daily basis, patching data, patching code, patching queries. And I've really concluded that probably just about every organization has this kind of problem, because I see it so much. I've come to expect it. The real desire that we should all have is to understand how we can get over this peril. What can you personally do? And what can your teams do to not have these kinds of problems? So I'm going to start out looking at what I think is odd about the industry that we're in and the reason why we have these problems. We may actually conclude, following the discussion of these odd ideas or odd problems that we have, that the people who want to do something about it, to make a significant change in the industry, could actually be the odd people. Because the problems that I see are so common. So let's talk about these. The major problem that I see in a lot of companies is that the software development teams, or the software development department as a whole, is considered a cost center. This is where teams of software developers and computers themselves are seen as a necessary evil. The company must use computers because we're dealing in a modern age, contemporary with computers and software being used everywhere. But the company wishes that they could actually do business without computers. And so they view oftentimes software developers and the entire software development organization as a cost center. Is that how it's viewed in your organization? What can be done about it? One of the big reasons why software developers are viewed as a cost center is the general attitude of the individual software developer. This is where the software developer is viewed by the company in this light. They're seen as the uber geek, the person who is trying to solve business problems with technology. And so whatever the next technology fad or craze is around the globe, it's developers like this who are chasing after new technology solutions, trying to say, we can solve this business problem with this technology. And I think that this gives software developers a very bad name. I don't think that it helps us to have a good reputation within organizations, and it can lead to us being viewed as a cost center within the organization. Oftentimes, the shiny new objects that developers chase after have to do with a database, a new database technology. Now, in years past, it was relational database. We all had to use relational database, and if we wanted to use objects with relational database, we had to use object relational mapping. But then came along NoSQL, Cassandra, MongoDB. Now there's a Cassandra competitor named Scylla. Are we chasing after the database? If we're chasing after the database, do you know what happens? We often view the business in terms of a database. In fact, on a recent project, we had some clear business initiatives, but the developers and QA on the project could only refer to each of these systems or services that were being developed, and the legacy, in fact, in terms of the database. They said, Oracle, when we are processing data in Oracle, or when we're processing data in MongoDB, for example, so everything was stated in terms of the database. And when we are database driven, often our attitude changes and we are not really addressing the needs of the business. All kinds of shiny objects exist that developers chase after. XDD. Is it TDD today? Or is it BDD today? Or is it DDD today? Big data, machine learning, deep learning. What's the difference between big data, machine learning, and deep learning? Actually, I'm not sure. 5 years ago, you should have been working on big data. Today, you better not be working on big data. You better be working on machine learning or deep learning. They all have a lot in common, but if you work on big data today, not so popular. In fact, you should really have on your resume artificial intelligence. Are you concerned about things like that? Are you chasing shiny objects? And how does chasing shiny objects make you look to the business? Here's another insidious problem. It doesn't matter what you name it, it's just code. I actually heard this said in a meeting where, in collaboration with business experts, we were having a deep discussion about the business software. We were having a deep discussion about how the business mental model was going to be projected into code so that the system would align with what the business needed. And one of the developers said, "Why are we having this conversation? It doesn't matter what you name it. It doesn't matter what you call it. It's just code." This is actually a big problem because developers who have this mentality are actually pushing themselves away from the business in their very attitude. I also see poor collaboration. And a lot of times what I see is teams are separated from each other individually, working through Jira, creating specifications. Business people will be in their office or their cubicle creating specifications. Developers will be in their office or cubicle or table working on specifications, all separated, not having conversations, but rather using Jira as a means to create specifications. And you know one of the biggest problems with this? It's actually, to a large degree, not consumed. Because a lot of times, the specifications, the stories, and so forth don't align with the actual business needs because there haven't been enough deep conversations about the topic, about the system or service that's being developed, and so this causes problems. Another problem that I see is estimations. Software development teams are constantly grinding through the need to create estimates about how long it will take on this sprint. How long will it take for this release? And I have actually seen entire sprint timelines used in order to create estimates for the sprint that isn't getting worked on because the business wants estimates. This is a big problem. If you're not building software, if most of what you're building are estimates, then we're missing the point entirely. I also see this, what I call the task board shuffle. The task board shuffle is where you have a sprint board, a product backlog, with a to-do column, an in-progress column, and a done column. And each morning, you have your meeting, your team huddle, and someone says, "I'm going to volunteer to work on this," and they peel up the sticky note from the to-do column, and they shift it over to the in-progress column. When they walk out of the meeting, they walk back to their desk and start coding. The entirety of design thought was given during peeling up the sticky from one column and moving it to another. Therefore, our software is often lacking good design, effective design, and believe it or not, it is still design what that developer is doing when they walk out of the huddle and go back to their desk and start working on the code. It's still design. It's just really, really, really bad design. And think of what it's going to be like to live with that bad design for a long time. This often turns into systems that are known as big balls of mud. Even brand new systems that are fresh off the keyboard, just months old, become big balls of mud. This is where you have many tangled models, and the tangled models are working against each other. And in essence, the team that's building this, or the multiple teams building this system, view the models as working together, and yet they don't really work together. This is a big, big problem. The system often starts out small and manageable. It makes sense, but then it grows out of control with many, many supporting concepts, and we end up with a big ball of mud. I see business logic mixed in with persistence code. This means that some core understanding and process around the business is lost in technicalities, in technical structure, in technical logic that is meant to put data on a disk. You don't want to lose business logic this way. I see queries inside business logic, mixing persistence and business logic again. So kind of the opposite, but a very similar problem. I see broken queries, where queries are actually locking the database for long periods of time, blocking other queries, blocking operations from happening because the queries have such complex joins that they're causing major locking. And even besides that, the queries themselves are so complex that it's difficult to get them right. It's difficult for someone to even understand the complexity of the join to make this data retrievable. And what I find also is that many times in batch processing is that most of the batch window that runs probably in the middle of the night with maybe a 2,000 line query or a 3,000 line SQL query, what's happening there is that we're constantly trying to figure out what happened the day before in the business so that we can act on what happened the day before in the business now in the batch window. The actual batch processing, the processing that needs to be accomplished during this time, is very, very minimal. Most of the time is spent querying, trying to understand what happened the previous day. Business logic in the user interface. When the user interface changes, sometimes the business logic changes. How do we have a good understanding of where the business logic, or what the business logic is, when it's residing in several different places throughout the code? I also see that along with a database mentality, a database-driven approach to software development, that we generally fall into a CRUD and anemic domain model situation. CRUD, of course, stands for create, read, update, and delete. But this is where the software is so data-driven that the users actually have to have a deep understanding of how the business works so that they can encode in the data so that the data will be validated and correct according to what the business rules are. Because CRUD software and anemic domain model do not help the users understand what the business needs. I also see wrong abstractions. How many here have seen a problem that the business needs to solve, and the developers say, this problem could be solved again and again if we model it, if we design it to be highly abstract? Meaning, for example, I have these 4 business forms that need to be filled out by users. What if we have a fifth business form that comes up later as a requirement? What if we have a sixth business form? What if we have 10 business forms that have to be filled out by users? Wouldn't it be worthwhile to develop a forms processing abstraction so that we can fill out the 4 forms, and just in case there are 10 forms that need to be filled out by the users for the business sometime in the future, maybe even a year from now, we'll already have written the code, and all that we have to do is plug in some new data to drive the forms. It'll be a cinch. It'll be no problem at all. The problem is the abstraction covers up the actual business needs. And it's very unlikely that you will be able to reuse this code in the future because you can't anticipate what the business will actually need months or a year from now. Wrong abstractions take us down the wrong path very often. And this is also an insidious problem where we are trying to build small services, even microservices, but those services are actually tightly coupled together because there are dependencies and even RPC, or remote procedure call, dependencies between microservices. And so those services are very brittle because they depend heavily on each other's interface, programming interface, or API. So all of these problems add up. You know, if you think about it, even if any given project had only half of these problems, it would be a considerable load and drain on the success opportunities for this project. So the question is, what do we do about this? I think that in many ways, this kind of software development that I've just shown you and the problems, the perils that we face because of them are really very normal. It seems like maybe that is what is normal among software development projects. So maybe we, the ones who care about doing something about this situation, maybe we are the ones who are the odd people. Maybe we should be odd. How do we take our situation of being odd to the end? Actually, notice the second definition under the noun end. The second definition says that the end is the furthest point or distance, the extreme part or point of something. So actually, if that is what is normal, what I just described previously, wouldn't you like to be the odd person? Wouldn't you like to be at the furthest point from the odds of poor software development? So the first thing that we have to do as developers, as individual developers, is change this perception of us. We should not be primarily technologists. We actually have to rise above being the uber geek, and we actually have to have a business sense about us. We need to prove that as software eats the world, it's eating the world because the business drivers are motivating us to create business systems that address the competitive needs of each business. How do we do that? We have to mature as developers. We also have to, in order to mature as developers, educate ourselves. And you know what? You know what I think? I think every single one of you should be doing what I'm doing right now. In fact, I think that in order for developers to mature, each of you should be teaching your colleagues at least 5 days a year. You should actually be developing courses around good software architecture, good software design, good organizational structure that supports good development. If, for example, you may have, let me skip forward just for a moment. You may have seen this talk just prior to mine. James Lewis gave the talk on microservices and Conway's Law. Teach about this. Teach about Conway's Law, and teach what James Lewis taught, that it really matters the way that you structure your organization, the way that you structure your teams. It really will make a difference. We also have to be quite passionate about what we do. I think that you're at this conference because you're a passionate developer. I really believe that. And so, because of the passion that we have toward software development, make yourself a business software developer, a software developer that addresses the competitive needs of the business. Make yourself a partner to the business. By doing so, you will engender the attitude that software development in your organization is not a cost center. You are actually a profit center, because you are creating competitive advantage starting with your team and then having an effect and growing this out throughout the software development organization. Being a profit center will put you in very good graces with the business. I already mentioned James Lewis. If you didn't get to see his talk, and I'm pretty sure that they have video recorded James' talk, I hope that you take the opportunity to watch and listen to that talk very carefully. Very well done, and I won't go into it more, although what I will say is that we have to collaborate as teams. We have to set up our teams, for example, in terms of microservices. If we want to develop microservices, our teams should be formed around microservices. We shouldn't make Jira and the use of Jira more important than we make conversations. Deep conversations about the business and the business's mental model and the way that the business will be more effective, more competitive, is far more important than specifications that get saved into a cloud and sometimes rarely, if ever, consumed. This will actually help to make your team a profit center, collaborating as a team, developing what in domain-driven design terms is called a ubiquitous language. You have such a clear understanding within the team of how your microservice or your bounded context works that you know exactly what the code should look like. You know exactly how the code should work, because the code is actually a reflection of the conversations that you have as a team. To do that, you need to develop concrete scenarios. Scenarios that truly do reflect what the business needs to accomplish. You can do this using unit tests or BDD. It doesn't really matter how you do it, as long as you have the conversations that are reflected into concrete scenarios that become acceptance tests for your domain model, where you actually can sit down with a business expert, a domain expert, and allow them to read the code side by side with you and ask them, does this match your mental model? Does this software work the way that we discussed as a team? No? Then what changes can I make? Let's get together as a team and have another discussion so that this acceptance test can fully reflect the ubiquitous language that we care about as a team. And as you do that, you will create deep models that reflect a very, very deep understanding of business strategy. This is actually the shiny objects that we should be chasing. This is the kind of gold, so to speak, that we should be most interested in as developers. And it's very rewarding. So along with the ubiquitous language, each ubiquitous language is separated into a different bounded context. This is where a context exists that allows your software to have specific meaning in that context. This means that when I speak a term or a concept or talk about a behavior or a process with my team, everybody knows exactly what I mean when I speak this because we have a context. Context is so important. And this context should be drawn around each ubiquitous language, and the context should be different from the other contexts. And this is where you can align microservices. Instead of building tiny, tiny services and deploying hundreds of services to fulfill one system, actually consider using bounded context and the ubiquitous language to drive the size, to determine the size of microservices. This approach is far from a monolith or big ball of mud, so it's quite a bit smaller than a monolith, yes, but it's also larger than deploying one entity as a microservice. So you could say that a microservice that is developed in terms of or within the context or boundary of a DDD bounded context, it's right-sized. It's actually the size that a microservice needs to be to participate in an overall system. And here you see 6 different microservices, and notice the one in the middle is the core domain. This is where you're going to concentrate your core efforts with your best developers, with those who have a true passion and have a good understanding of what the business needs are and have the desire to fulfill the business competitive needs. This is where you're going to put those developers, in the core. Then the less mature developers can learn to have passion. They can grow their passion and their education in these other areas. But you want to put your best into the core domain. Another technique that's going to help us to accelerate our timeline, to deliver software more frequently and more accurately, is to use a technique that's called event storming. I don't know if you have heard about event storming, but it is a very, very powerful approach to software development. What you essentially do is take just a few colors of sticky notes, and each color of sticky notes represents a different kind of component in your software model. You start with domain events. And so if you see on this particular diagram, The orange sticky notes represent, the yellow sticky notes represent domain events. So what you do is you start out by having someone, like a business expert, put on, say, a whiteboard or a long sheet of paper, one event that says, this happened in our business. And then we start to build out a set of events in a timeline that show the entire business process. This helps the team focus not on data, but on the business process. And any time that you go through this exercise, it will help you and your team to understand. It will help you to build a big picture model and detailed design level models that help you to understand the business process. And you relegate data to almost the last priority. You are concerned about data, but you're giving higher priority to the domain events. And I will say that this technique is explained in a detailed way in this book that I'm going to give away. So try to learn something about event storming and use it. Now, as you use event storming, the artifacts of the sticky notes that come out of this process can be used in a metrics-based estimation approach. So you can actually build estimates based on your discussions as a team on the artifacts that come out of a design level event storming session. Now you can actually place each of those artifacts with a time estimation from a metrics-based table, and you can now estimate very rapidly how long it will take to build, to develop each component and the tests for each component. And as you understand your cadence better throughout the project, you can tune the metrics-based table to make it more accurate as the team becomes more close-knit over time. You have to understand good architecture. Understanding good architecture is paramount. You have to know what kind of architecture fits into a microservices environment. Should you be using a hexagonal architecture, or what is also called ports and adapters, or onion architecture? Should you be using a different architecture? What are the adapters that you should have in your ports and adapters architecture? What kind of API should we have? What kind of domain concepts are most important to fulfill the needs of the business? CQRS stands for Command Query Responsibility Segregation. This is where you develop within your architecture two kinds of interfaces. An interface that addresses the incoming user commands to perform an action, and the queries or requests for data. So you're going to tune each model to adequately allow selection of data, whether it's for executing a command or whether it's for performing a query. And the query model will be tuned so that the actual queries that you need for user screens or for management reports or for business intelligence, whatever it happens to be, these queries will be tuned to return the data with just one or very few business level IDs or identities of the entities that you're querying. This allows you to cross-cut through the command model and view data in the way that the user needs to see it using use case optimized queries. You need to use proper abstractions. So if a business, for example, I use this case of creating a framework or a mini framework or library to address forms processing. If the business has 4 forms that need to be filled out by users, model each of those forms in terms of the actual business needs. Don't take the time to abstract into a forms processing system. If you create an abstract forms processing framework in order to process the future 10 forms that could happen, that could be used over the next year or so, you're actually going to take on more burden of code maintenance, and you're not going to be directly addressing what the actual business needs are. And when domain experts want to look at the actual forms that are being filled out, they would not be able to understand because the abstractions are wrong. So properly address the needs of the business by the abstractions that you use, and address those as the key concepts from the conversations that you have as teams. You also need to decouple services. How do we decouple services? One of the best ways to do that is through asynchronous messaging. So you actually want to publish domain events out of a microservice, and then through a messaging mechanism, other microservices can become aware of what happened in your microservice and how they can react to that. So you're actually creating reactive microservices by decoupling. And another comment about reactive microservices is to seriously consider using the actor model, because I don't know if you've noticed, but processor speeds have flatlined. Intel and other processor manufacturers, AMD and so forth, are not creating faster processors. Not to the extent, anyway, that we were seeing 15 years ago. And so, how are we going to make use of the multiple cores, the many cores that are common in the servers that are used by us, consumed by us, in the cloud, in our data centers? It's going to be by making full use of the ability to use threads. And the actor model is one of the best ways to do that, because you have to have a very minimal understanding of threading, but a maximum understanding of what kinds of messages need to be exchanged between actors. Everything in the actor model is lock-free. There are no locks. Everything is asynchronous. And you'll see the system using all of the cores on any given machine to its highest extent almost all the time because of this kind of approach. So take a look at systems like, or tools like Akka and Play Framework that will help you to develop truly reactive, highly responsive microservices. And this is what I mean. You can actually boil away a lot of the architecture that's very common in end-tier enterprise software, and you can actually just minimize to the controllers that are used for your UI or for your REST endpoints, the actual messages that are coming in as requests or actions, such as this one. We have an order book command that is being sent directly to a domain object, which is the actor book order, and the book order is going to persist its book ordered event to an event journal, and that event journal will then be read in order to inform other microservices that this particular book was ordered. How would you like to work with an architecture that is this simple on a microservice level? This can be done with actor model. So I just wanted to reference my other two books, Go Reactive with reactive messaging patterns with the actor model, and also I wanted to point you to this book, Domain-Driven Design Distilled, which I'm now going to give away. We have a few minutes for questions. What I'd like to do before the questions is just draw a name out of the bag here to win the book. And I'm probably going to call on, you speak Polish, I assume? Okay, I'm going to have you read the name. I tried doing that yesterday and I wasn't very successful. Okay, two stuck together.
Violetta Goździk.
Okay, come down. All right, so we have just actually less than a minute for questions. Any questions come to mind, or you can come up after the talk and we can meet here during the break. Okay, thank you very much for attending.